After all the bad publicity received by WEP, the IEEE had several items on its wish list of items to fix. One of these is that it's not a good idea for all the stations in a Wi-Fi LAN to share the same key, because that means that if one of these stations is compromised and the key gets out to an attacker, then everyone's security is compromised. 802.1x is one solution to this problem that allows each station to use separate credentials for its encryption and for its authentication. It also provides some other security benefits that we will talk about. As its name suggests, it was not originally designed for Wi-Fi security specifically, but it is under the 802 umbrella. That's why 802.1x. In fact, 802.1x was originally designed for Ethernet and then generalized for other 802 LANs, because even for Ethernet, it's useful to have network access control, and 802.1x is a good way of doing that. You have authentication and access control tied together by the 802.1x framework in a flexible framework. The key entities in 802.1x are a supplicant, which is the device wishing to access the network, an authenticator, which is like a guardian of the network entry point, and then an authentication server, which is an identity verification service, which may support multiple means of verification. Now let's compare this with what we have seen before for WEP. In WEP, there is a supplicant, which is a station that wishes to access a network, and then the access point acts as both an authenticator and authentication server in the sense that it is the guardian of the network entry point, and it also verifies the identity of the supplicant. But as we saw in earlier videos, this authentication part is a bit weak. If it's just based on having knowledge of a shared key, it's very weak. So there's much better authentication that can be done, and 802.1x helps us to do that. So we have seen one of the key features then of 802.1x is that it separates the guardian of the network entry point from the identity verification service. There are a couple of benefits of doing this. Imagine if we didn't have a separate identity verification service, but every access point, every guardian of network entry, needs to be able to decide whether to let any supplicant in. Then every access point would need to have all the security related information, all the credentials, and it's not a good way to do that, because then the network becomes less secure. Rather, it's better to securely keep various credentials and authentication related functions in a central server like a Radius server. And this can function as the identity verification service, leaving the access points to focus on their job of guarding the network entry point. Furthermore, 802.1x also provides for flexible end-to-end authentication between the supplicant and authentication server using EAP. This has actually two benefits: the flexibility and the end-to-end. In terms of end-to-end, that means compared with the browser hijacking model that we had seen in an earlier video, now the supplicant talks directly to the Radius server, the identification verification service, and does not have to reveal its credentials to the authenticator even, which is somewhere in between. The flexibility comes from the use of EAP, which is Extensible Authentication Protocol. It supports multiple different authentication protocols in a flexible way. Some of these even allow for mutual authentication, two-way authentication, which is authentication of both the server and then the supplicant. There's another concept that we will briefly mention here, and then we will take a look at the flow chart to explain this further. So this is control port versus uncontrolled port. This is a logical concept at the authenticator, which in this case is the access point. Basically, the access point will have two ports for traffic from the supplicant, and the control port is the one that it does not allow the supplicant to use, does not allow traffic from the supplicant to pass through the control port until authentication is successful. So only EAP related traffic can pass through the uncontrolled port and move on to the Radius server. Here is the diagram showing how these things are put together. We have a supplicant, which is the station, and an authenticator, which is the access point. And there's different places that the authentication server could be located. In this case, we have an example where it's in a separate network. And you can imagine that perhaps the station is roaming from its home service provider. So the authentication needs to happen at the home authentication server, which is possible with Radius, because Radius will help to locate the authentication server. So then we see that the EAP authentication is end-to-end, and it can be protected with PEAP or TTLS, so you have a secure encrypted end-to-end channel where even various legacy username and password based authentication methods might be supported. Things like EAP MS CHAP v2, for example. The flow of 802.1x is as follows. First, there is initialization, where the authenticator port for the supplicant is set to unauthorized, meaning that the control port is closed. So only the uncontrolled port is open for traffic from the supplicant, because this is the port that it needs. It needs to at least be able to have some communication through the network so that it can attempt authentication with the authentication server using EAP. And so that's what is allowed. Initiation is where the authenticator sends an EAP request to a special layer 2 address, and the supplicant responds with its identity, which then can be forwarded to the authentication server. EAP negotiation also needs to happen because there's different EAP authentication protocols that are supported by EAP, since it's extensible and flexible. And then the end-to-end authentication between the supplicant and server can then happen. Upon success, in the case of Wi-Fi, when we're using 802.1x with Wi-Fi, upon success, then the master key for this session is returned. And also the authenticator opens the control port to the supplicant so that all traffic can pass through.